We'll proceed in innovative approach in calculus and we'll try to to bind up the product rule. Innovative approach in calculus. So we are not reading calculus, we are doing calculus. So that is the idea. And when you do something, then as per your nature, you will try to find some path with your nature also. And that's how you invent something. Invention always comes from inside. And when you start thinking something from your nature, then certainly you will try to trace out some different kind of path. That is invention. Anyway, we have done some new approaches. We have achieved some new approaches in calculus, and that is what we are trying to discuss. So, product rule, we have achieved one way of calculating the product rule and product rule in differentiation. If I have a function fx and if I have a function gx, then what is differentiation of fx and what is differentiation of gx? That is people know. What about differentiation of fx into gx? dfx into gx, dfx into gx divided by dx. Okay, so that is what we are trying to look for. And there are many ways that we can find this product rule. Differentiation of fx into gx by dx. What is by dx that we have seen in the detail? What is by dx? Okay, so normal life, general life works in numerical fundamental. Normal life does not work in algebra. I cannot go to a shop and then I ask for orange. I mean, I can ask for orange, but I cannot go to the shop and I ask for how many oranges you want. I want X oranges or X kilogram. Then he will certainly think that you are a deranged person. But I am thinking, I know algebra and calculus and this kind of thing. I'm asking in kind of X number of orange and Y number of guava and this kind of thing. So normal life works in numerical science. Mathematics is a science of numerical science. Mathematics is not science of algebra, calculus, vector field, different coordinate system. I cannot go to any normal person and say that let's talk in Cartesian coordinate and let's talk in a spherical coordinate and let's talk. These are made algebra onwards, whatever the science we are seeing, different coordinate system and parameterization, this is to solve the complex numerical problem only. At the end, it is numerical. How far the sun is, I cannot say integrate and differentiate and then go to that coordinate and then substitute here and there. You will find distance to sun. Person will think I have come to a mad person. But you may be right because directly computing the distance may be difficult. With some derivative here and there, some changes here and there, it makes sense. So 99% of mathematics is numerical mathematics. 1% of mathematics is algebra, calculus, different coordinate system, vector field. Person who is powerful in numerical science, he is powerful in mathematics. Not person who is weak in numerical science and very strong in high class multivariable calculus. So that is not true. Anyway, now what is dfx by dx? dfx by dx, if dfx by dx, x x x axis. So if I have x axis, so if I have x axis and there is a curve like this, I have demonstrated many times. If there is a curve like this, then what is the equation of this curve? Or I would rather say I have a Okay, so I made it. So this is x-axis, and there is a curve like this. Curve is a circular curve. What is what about or curve is like this. Now it make more sense. Curve is like this. Now at point this is x-axis. This is x-axis or curve is centered at the origin. If curve is centered at the origin, this is origin. This is x-axis, this is origin, this is minus x-axis, this is y-axis, this is minus y-axis. Okay? If I say at point this circle is of radius a, then at point a comma 0, what is the y? What is the y? 0. At a comma 0, what is the y? 0. At 0 comma 0, at when x is 0, when x is a, y is 0. When x is 0, y is a. When x is x1, what is y? What is y? This y is called fx, function over x. Function over x means if x is changing, then y is changing. Y is dependent upon x. When x is changing, y is changing. In that sense, y or the height, what we say, is the, if I take any point, it is x comma y. Any point, x comma y, where x is independent and y is dependent upon x. Y is also called function over x. There is a relationship between x and y. Both are not independent to each other. In three-dimensional, z is dependent upon x and y. X and y are independent to each other. Here, x and y are dependent. Y is dependent on x. X is not dependent on y. X square plus y square equal to a square is the equation of a circle. X square plus y square equal to a square. Y equal to square root of a square minus x square. Means y, if I consider function over x, then if I keep changing x as a formula square root of a square minus x square, fx would keep changing. Okay. Now what is the differentiation? If at point x, any point x, if I have this as fx, okay, or okay, at any point x, this is the fx. At any point x plus delta x, I'm moving delta x unit. Delta x unit. Let's consider x-axis is on unit, 1 unit, 2 unit, 3 unit. What is unit? It depends. It may be millimeter, micrometer, picometer, meter, kilometer, whatever. Now, if I have a point x and I am moving delta x, then I have 2 points. One is x plus delta x. At x, what is the height? That is function over x. At x plus delta x, what is the height? That is function over x plus delta x. Okay, if I move delta x from point x, then how much in height I am moving from fx to fx plus delta x? Because I moved delta x, there I am moving fx plus delta x. Then it is fx plus delta x minus fx, that is the height moved because I moved delta x from point x. That is dfx by dx. Dfx by dx means if I move 1 unit of distance along x-axis at any point x equal to x, at any point x on x-axis, from there if I move 1 unit, then at x, if there is a y, that is fx, then at x plus 1, what is the new fx? If I differentiate these two fx is means fx y climbed dy by dx. Y is climbing, right? If y is at or declining, whatever it is. So if this is x-axis, this is point x, and this is y. At point x plus 1, y is different. How much y climbed? If x changed 1 unit, how much y climbed? dy by dx. If x is changing 1 unit on x-axis at point x, then y is climbing how much? That is dy by dx. That is differentiation. People also call differentiation. Okay. Basic of calculus is integration, that we have seen, and integration is nothing but finding the multiplication through calculating the area. Multiplication is nothing but finding the repeated addition, finding the addition, new form of too much addition is multiplication. How to find multiplication? People tend, they have formula. Okay, like if I am collect first kilometer, I am walking. First hour, I have collected 1 kilometer. Next hour, I have collected 1.5 kilometer. Next hour, I collected only half kilometer. This is the way I am walking. And then next hour, I collected 4 kilometers. Okay. Then what is the net collection? Then addition. You add it. And then say in 4 hours, I collected this much. First kilometer, I collected or I walked 2 kilometers. Next hour, I walked 2 kilometers. Next hour, I walked 2 kilometers. Next hour, I walked 2 kilometers. 4 hours. How much I walked? Or next hour, up to 20 hour, every hour I am walking 2 kilometers. How much I walk? 2 plus 2 plus, why you are doing this much? 2 into 20, 40 kilometer you walk. So multiplication is nothing but repeated addition. But main thing is addition. Mathematics begins from addition. So if I'm trying to calculate the addition and it is repeated, we can multiply. If it is not repeated, like first kilometer, 2 kilometer, first hour 2 kilometer, next hour 1.5 kilometer, next hour 3.2 kilometer, next hour 0.25 kilometer, next hour 4 kilometer, like that someone is walking for 20 hours, then how I can calculate how much he has walked? Multiplication would not work. What would work? The question is, what would work? If that is the case, then what would work? Then there is another way someone can draw a x-axis between hour, 1 hour, 2 hour, 3 hour. At each hour, someone has to find at what distance he is. What is the velocity at that point? So at first hour, the velocity is 1 hour he walked 2 kilometers. So at first hour velocity is 2 kilometers per hour. So speed is 2 kilometers per hour. That I point. Now next hour he walked 3 kilometers. 3 kilometers. So at that in next hour his speed is 3 kilometers per hour. 3 kilometers per hour. Like that you draw a point and there will be a graph of velocity hour graph. If someone draws the area, if someone calculates the area underneath the velocity that is integration. Integration is nothing but calculating the area of a graph. If I calculate the area of a graph, area means two sides. One is width, one is height. Height is varying. That is the velocity. That is varying. If height is varying, I have to bring in a graph and then I find the area. Area is the net distance traveled. This is the also way we calculate the addition. Addition is not only addition, addition can be calculated through multiplication also, repeated addition, or non-repeated addition can be calculated through addition and it can be calculated through calculation of the area. Then someone need to, if velocity graph someone is drawing, someone has to find algebraic equation of the velocity. That is the idea. If algebraic equation comes, then someone can draw anything. It can be sinusoidal, it can be logarithmic, whatever. If someone finds the area underneath, that is the net distance travel. Or if someone has net distance travel, if he place derivative along the x-axis or along the hour, then he gets the velocity back. That is differentiation. D distance by d hour is velocity. Velocity d hour integration is net distance, opposite to each other. But anyway, we are in phase of calculating product rule in calculus. So product rule, if I have x-axis and if I have a function is nothing but height. Function is nothing but height. This curve has equation x square plus y square equal to a square because you have circle. That is y equal to or fx equal to square root of a square minus x square. If that is true, keep changing x everywhere and you keep calculating fx. Fx equal to square root of a square minus x square. If that is the case, dfx by dx, dfx by dx is how much height is changing at any point on x-axis. Point is name is x on x-axis. If it moves by, if I change one unit, then how much y is climbing? How much fx is climbing because of one change, unit change along the x-axis? dfx by dx. What about there is another function called gx, dgx by dx. What about dfx into gx by dx? Or simply someone can say, what about derivative of fx into gx? What is derivative of fx into gx? So the method what we propose calculating it is three-dimensional. Three-dimensional in a sense that I believe I should not repeat it again because many times we have done. If this is x-axis, this is x-axis, this is x-axis, I'm sorry, this is xy plane. If this is x-axis, this is y-axis, this is x-axis, this is y-axis, this is z-axis. A surface is kept on xy plane. If surface is kept on xy plane, if I keep y-axis, this is x-axis, this is y-axis, this is y-axis. If I keep y, hold y and move x-axis at any point x1, how much z is moved? That is dz by dx at point x equal to x1 into x. If I hold x-axis and move y-axis at any point y1, how much z is moved? How much height it achieved? That is z equal to dz by dy at y equal to y1 into y. If I do both, first hold the y and move the x, and then hold x and move the y. At any point x comma x1 comma y1, how much z is moved? That is addition of both. Then z is moved at dz by dx. Slope into x, that is z. Slope into y, that is z. So net z is both z what we achieved. So z equal to dz by dx at x equal to x1 into x plus dz by dy at y equal to y1 into y. That much z has moved. Okay, very nice. Whatever you talked is very nice. Anyone would say. Okay, I have another one. Yay! I have real three dimension. So this is a surface and consider this is xy plane. This is x axis, this is y axis, this is z axis. Now this is the surface that is sitting somewhere in the sky. This is a surface. Okay, this is a surface, this is a flat surface, this is a surface. Now at any point what is the tangential surface? How I can find tangential surface? Everywhere tangential surface is different. What is tangential surface? What is tangential surface? That is the question. Okay, what is tangential surface? What is tangential line? If this is a circle, what is tangential line? This is tangential line. That is at any point, this point is called x comma y. This point is called x comma y. This point is called x comma y. Consider this point is x1, y1. At this point, if I calculate dy by dx at x equal to x1, y equal to y1 or x equal to x1, that dy by dx is called slope. So if I draw a line here with slope what I calculated, point is x1 y1. At point x1 y1, I draw a line whose line will have a slope, right? It will have a slope. If slope of the line is dy by dx that is calculated at x equal to x1, then it will be exactly tangent at this point. So every moment if I calculate dy by dx and set the x, whatever the x is, that is called tangent line. Similarly, if I have 3D surface, and if I want tangential surface, now this surface is tangent at every moment. What is the equation of the tangential surface? Their tangent line. What is the equation of tangent line? Y equal to dy by dx into x. If it is passing through x1 and y1, then y minus y1 equal to dy by dx at x equal to x1 into x minus x1. Similarly, what is the 3D? What is the equation of the surface? What is the equation? What is the equation of the surface? Oh, this is good. Okay, what is the equation of this surface in 3D? Okay, then equation of this surface is analogous to the, if we remember just now I derived z equal to z equal to d z by dx at x equal to 1 into x plus dz by dy at y equal to 1 into y. That is at any point x1 y1, what is the z value? What is the surface equation of any flat surface? That is z equal to dz by dx at x equal to x1 into x plus dz by dy, y equal to y1 into y. If that is the case, then what is the equation of surface at any point? If this is xy plane, at any point I take x1 y1, any point x1 y1 on the xy plane. If I get z value for it, fxy, then it go up and hit here. This point is x comma y comma z, where z is function over x and y. This point correspond to x1 y1, so it is actually x1 y1 comma f xy at point x equal to x1 and y equal to y1. What is the equation of tangential surface here? Okay, what is the equation of tangential surface here? So equation of tangential surface here, the equation, what is z value at x1 and y1? That is the equation of the tangential surface here. That is z equal to dz by dx calculated x equal to x1 into x plus dz by dy calculated y equal to y1 into y. That is the equation of tangential surface z. I believe it's all right. Or if someone asks, okay, I talked about too many things, I believe so. So what is this z value? If I get z value, the equation of surface, that is a flat surface, is nothing but value of z only. Okay, so what is z value there? What is z value there? If I say what is the equation of line, if I have a circle like this, and what is equation of this? What is equation of this line? This line, tangential line, y equal to dy by dx, that is the slope into x. But that is the height. That is the height. If I have a line and this is the slope of line is dy by dx and then multiply by x, that is the height. That is the equation of the line. Okay. Line is nothing but a point of y only, right? Y is here, 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 and then draw the line. Similarly, what is the equation of tangential surface? That is nothing but z value. So z value is dz by dx, x equal to x1, x plus dz by dy, y equal to y1 into y. If that is true, z equal to like that. What about delta z? What do you mean by delta z? Okay, I told you that any point of tangential surface, if every point, if I draw a tangential surface, at any point, the point is x1 comma y1, if that is the point on the xy plane, corresponding I have z value, then the equation of that surface or z, the equation of z is nothing but z equal to dz by dx and x equal to x1 into x plus dz by dy, y equal to y1 into y. What do you want to know? I want delta z. What do you mean by delta z? Okay, now if it is, okay, okay, consider this is xy plane. This is origin, blue color is the origin. Now, if I take any point x comma x1 comma y1, any point x1 comma y1, if this is the surface here, this go and hit some point on the surface. This go and hit some point on the surface. What is that point? That is x1 comma y1 comma z. What is z? Z is function over x and y. That someone has to define. That will define the nature of the surface. If that is true, then what is z? What is z at x1, y1? That is fxy or fx1 comma y1. That is z. Now I move delta x along x from x1 and I move delta y from y1. What is your new point? New point is x plus delta x1 plus delta x comma y plus y1 plus delta y. There is a new point. So old point is x1 comma y1. New point is x1 plus delta x comma y1 plus delta y. There is a new point where I move little bit delta x, not little bit, delta x distance from x and delta y distance from y. Then what is z? Then z is function over x1 plus delta x comma y1 plus delta y. That is new z. Very nice. At x1 y1 what is z? That is f function over f x1 comma y1. What is z at new point, that is x1 plus delta x comma y1 plus delta y? That is function over x1 plus delta x comma y1 plus delta y. Very nice. How much you moved in x? I moved delta x in x. How much you moved in y from point x1 comma y1? How much you moved in y? Delta y. How much your z moved? If you were at x1 y1, there was a z value, right? Now if you are at new point, that is x1 plus delta x comma y1 plus delta y, you are at new point, right? That is z1. Consider z and z1. How much z climbed if someone moved point from x1 y1 to x1 plus delta x comma y1 plus delta y? If someone moved along in xy plane this much, how much z moved? That is called delta z. Okay, how much z move? That is called delta z. If x move delta x, y move delta y, how much z move? Delta z. So if I have equation of a surface at point x1 y1, that is z equal to dz by dx, x equal to x1 into x plus dz by dy, y equal to y1 into y. If that is true, what about delta z? If it is z, what about delta z? Then delta is z equal to dz by dx into delta x plus dz by dy into delta y. If I want to calculate change in z, if I want to calculate change in z, then at change in z where z correspond to point x1 y1, then what is change in z where from x1 I move delta x and from y1 I move delta y. If z equal to dz by dx into x plus dz by dy into y, then delta z, someone can try. This is z. What about z1? What about z1? So z1 would be dz by dx, the change what we see, dz by dx point x equal to delta x1 plus delta x into x plus dz by dy where y equal to y1 plus delta y at that point into y. This is the new z. Now if someone is calculating change in z, it will come at delta z equal to dz by dx into delta x plus dz by dy into delta y. Delta x, delta y we know, x1. Now dz by dx calculated at x equal to x1, dz by dy calculated equal to y1. Delta x, delta y, what we move. So if we move in x-axis delta x, if move in y-axis delta y, then z would move like this one. Okay, that is delta z. Now consider z equal to x into y. This is our proof for the product. Now z, the height, is x into y. Z equal to x into y. What is delta z? What is delta in x into y? Delta into x. What is x into y? If z equal to x into y, what is z? Z equal to dz by dx, dxy by dx into x plus dxy by dy into y, calculated at some point. What is delta z? Delta z, where z equal to x into y, then delta z, delta x into y, delta x into y, differentiation of x into y. Delta differentiation is delta only, right? Delta, how much, this is dy by dx, how much delta y we are calculating if unit change is happening along x-axis. Now if z equal to, z is a function over x and y, dz by dx, delta z means dz by Delta Z means change in Z, change in Z when there is a delta X change and delta Y change, whatever it is. Now consider Z is a function of X and Y. That is X into Y. Why we are taking like this? Because we are calculating product differentiation of product of Fx and Gx. Fx is dependent upon x, gx is dependent upon x, true, but fx and gx, they are independent to each other. If they are independent to each other, fx and gx, they are independent to each other, they are analogous to xy plane 3D, where with two independent components if we are finding, then it will move we are moving problem to 3 dimensions, knowingly, unknowingly, we don't know. If I am saying what is product of fx into gx into hx, and all three are independent to each other, we are moving into density function, 4 dimension. People, they don't know. Okay, so if I am saying dfx by dx, we are in 2 dimensions, where one is independent component x and fx is dependent component. If I am saying what is differentiation of fx into gx, now fx is a function over x, fx and gx is function over x, but fx and gx, they are independent to each other. I can say fx is similar to x and gx is similar to y, where xy plane, where x and y are independent to each other. Then what is fx into gx? That is z. This is our proof, and this is the most solid proof. If that is the case, then if I have fx into gx or x into y, what is differentiation of x into y? Delta z or delta x into y. This is what we are trying to find. That is dz by dx into x plus dz into delta x plus dz by dy into delta y. Now z is x into y by dx. X and y are independent to each other. Dx into y by dx is y. Y into delta x plus x into delta y. So differentiation of x into y is y into delta x plus x into delta y. Now consider x equal to function over u, fu, and y equal to function over u, gu. X equal to fu and y equal to gu. If that is the if x equal to fu, function over one independent variable u, and y is function over one independent variable u again, x equal to fu and y equal to gu, then delta of fu into gu equal to gu into delta of fu plus fu delta of gu. This is the product rule, right? Product rule of function fx into gx or fu into gu is gu differentiation of fu plus fu differentiation of gu. This is the most solid hit on the product rule. When we are trying to calculate for differentiation of product rule, differentiation of two functions, knowingly, unknowingly, they are unrelated to each other. Differentiation of fx into gx is nothing but fx and gx are unrelated to each other. With respect to x, true, but fx and gx are unrelated to each other. It is as good as they are orthogonal axes, x-axis and y-axis. Then what is fx? We are trying to find differentiation of fx into gx, multiplication. That is a function over fx and g, that is a multiplication function, that is the z value. So z equal to fx into gx, delta z equal to dz by dx, dz by dx into x plus dz by dy into y. Now if I consider z equal to x into y, then delta x into y is dz by dx, dz by dx, dx into y by dx into x plus dx into y by dy into y. If x and y are two independent components, and z is multiplication of these two independent components, that is the z value. If that is the sense, then delta x into y is y into delta x plus x into delta y. Now anyone is free to substitute x with fu and y with gu. Then differentiation of fu into gu is gu delta fu plus fu delta of gu. That is the product rule. So we can prove the product rule by better means. Now I have one more way to find the product rule. What is the first principle to find the product rule? First principle in finding the product rule. So, first principle to finding the differentiation. What is differentiation of fx along the independent component x? Dfx by dx. That is nothing but fx plus delta x. This is what we showed. How much fx is climbing when there is a unit change along x-axis. Fx plus delta x minus fx divided by delta x. That is dfx by dx. What is dfx into gx by dx? Dfx into gx by dx. Fx plus delta x into gx plus delta x minus fx gx by delta x. Now what is now consider there is a curve. There is a curve. This is a curve. This is a curve. This is x-axis. Now at x-axis there is any point x. There is any point x. This is x-axis. There is any point x. And if I take x at this point, this is fx. Can you see? This is x and function over x is fx. That is the height y fx. This point height is fx. This point is x comma fx. If this point is x comma fx, then what about dfx by dx? Dfx by dx is the slope of a line. That line is tangent at that point. So at this point, this is the tangent. What is the equation of this tangent? That is y equal to dy by dx into x. So dy by dx or dfx by dx calculated at x equal to x. Or if this point is x1, then at this point if I calculate dfx by dx, then I have to substitute x with x1. Whatever comes, y equal to dy by dx, where x equal to x1 into x. That is the equation of a line that is tangential line at that point. That is also called that is the tangential line. Okay, that is true. Now what about if this is x-axis? If this is x, okay. So we got the tangential line equation is dfx by dx into x. Dfx by dx calculated at x equal to x1. Then that tangential line equation is like that, considering that pass through origin. Anyway, now I have at point x, I have fx. At point x, I have fx. What are we trying to calculate? Fx into gx, differentiation of fx into gx. Fx plus delta x into gx plus delta x minus fx gx by delta x. Fx I know, gx I know. What about x plus delta x in term of fx1? If I know this tangential line, the slope of tangential line is dy by dx, dfx by dx. Now, I am trying to calculate fx plus delta x. What would be fx plus delta x? Okay, if I have a tangential line, the slope is dy by dx. At any point x1, what is the y? dy by dx into x1. At any point x2, what is the y? dy by dx into x2. That is the y, or y2, y1, whatever it is. Now if I have this curve at any point fx, if I am estimating what is fx plus delta x, fx plus delta x, if this is the line at any point x, what is fx? If I know at that point what is dfx by dx, okay, if I move delta x, what is new f? That is fx plus delta x. That is fx plus delta x. What is fx plus delta x? Whatever is fx plus dfx by dx into delta x. What about new height? At this is x-axis. At any point x, I have height as fx. At x plus delta x, at that point height is fx plus delta x. Can I represent fx plus delta x in terms of fx? Certainly. If this is fx and at fx the slope is dfx by dx, then fx plus dfx by dx into delta x, that will give the delta height. So this height plus the delta height is the new height, that is fx plus delta x. So fx plus delta x is nothing but fx plus dfx by dx into delta x. If this point, if the point at which I calculated the dfx by dx, that point is x1, then it is fx1 plus dfx by dx calculated at x equal to x1 into delta x. Very nice. If that is true, if this is x-axis, if this is x-axis and this is fx, this is the curve and this is the tangential line, then at point, now if you watch very clearly, now at this point I know it is fx, the height is fx. If I move delta x along x, then I touch this point. I'm trying to estimate new height, that is fx plus delta x. This is x-axis. This is slope. Now at point, now x-axis I am at point x1. At x1, here I calculated dfx by dx, and then I substitute x equal to x1. Then I get dfx by dx calculated at x equal to x1. Now what is d? Now I move delta x. What is the height that is represented at x plus delta x? This height is x fx plus delta x. What is that? Then this height, that is fx or fx1, this height plus this. If I say the new height is fx plus dfx by dx into delta x, actually we are getting, if this is x-axis, this point is x1 and this point is x plus x1, and this is the slope, we are hitting this point because we are calculating the dfx by dx for this line, not this curve. At this point, what is the slope? That is, at that point, what is the tangent? At this point, tangent is different. I cannot estimate same thing. So if I say dfx by dx plus dfx by dx into delta x, then at point x plus delta x, I am hitting this point, not this point. This is point on the curve, this is point on the slope. If I want really fx plus delta x, then it is fx plus dfx by dx calculated at x equal to x or x1 into delta x plus some error, That is this error. Consider this is x-axis, then one point is x1 is here and x plus delta x is here. It is going and touching here. But since this is a tangent, I calculated at x, and if I say new x plus fx plus delta x is dfx by dx calculated at x equal to x1, previous point into delta x, that is this point, not this point. This much error is happening because curve is taking shape. We are doing all the calculation on the tangent line only. So if I say at point x equal to x1, the equation of at point x equal to x1, what is the height? Height is dfx by dx into x1, where dfx by dx is calculated x equal to x1. What is the height at x1 plus delta x? dfx by dfx by dx calculated at x equal to x1 into delta x. That is the net difference. That is, if I add, I get, but that is for the slope only. We are not getting the actual curve. So this much error is coming. So I can say fx equal to fx plus delta x equal to fx plus delta x equal to fx plus dfx by dx into delta x plus error, some error. That is this error, some error. Now gx plus delta x equal to gx plus dgx by dx into delta x plus error. Now I can substitute dgx into fx, differentiation of dfx into gx is fx plus delta x into gx plus delta x minus fx into gx by x. Now fx plus delta x I can replace as fx plus dfx by dx into delta x plus error. Gx plus delta x I can replace by gx plus dgx by dx into delta x plus another error minus fx gx by delta x. If you settle it down, it is very big term. If you settle it down, then things would come, the what you get is fx differentiation of gx plus gx into differentiation of fx plus whatever error term is there. that if I set it to 0 or h delta x, that is also 0, then more or less, probably we'll talk about it. Then it will come as fx into gx plus gx in fx into differentiation of gx plus gx into differentiation of fx. So probably this I will talk little more. Why I'm talking about error. I don't want to land up into situation where what is what is fx gx. Through first principle, people say it is fx plus delta x, gx plus delta x minus fx into gx by delta x. Someone can introduce here as gx plus delta x into fx minus plus gx plus delta x into fx minus gx plus delta x into fx. This someone can introduce. If someone introduces, then it becomes gx plus delta x into fx plus delta x minus fx by delta x plus fx gx plus delta x minus gx by delta x, that will come as gx plus delta x dfx plus fx dgx. But if you see this clearly, it is g plus gx plus delta x into fx plus into derivative of fx plus fx derivative of gx. Gx plus delta x, it is not gx. It should be gx into derivative of fx plus fx derivative of gx. This is the actually product rule. So first principle has an error. Why this error is coming, that we are tackling. So through first principle, fx into gx is gx plus delta x into derivative of fx plus fx derivative of gx. It should be gx derivative of fx plus fx derivative of gx. But it is not happening. So why error is coming? So that we are taking care of this. We'll proceed on this. Then we'll see many things. We cannot leave any stone unturned. Then people, what we say, delta x is 10 to 0. I consider it. Then consider everything 0 only. Why you brought delta x when it was 10 to 0? So why error is happening? If I consider this, then we can do many more things. So that we'll see. Please do support us. +91 is the India country code 94831606110. +91 is the India country code 94831606110 is the telephone number.